What is up, YouTube? EOS here, back at it again with another programming video. Today, I'm doing program 1 of my intermediate computer science class. Guys, we are on the road to 500 subscribers. Last time I uploaded, we had 5 subscribers. Now we got 16 subscribers, 16 big ones, guys. Remember, at 500 subscribers, I will be dropping that roommate review, and it's going to be awesome. So anyways, let's get into it. Program 1, make sure to like, comment, subscribe, absolutely smash that notification bell. And I have one more announcement for you guys. I have been uploading my files to GitHub. That's right. I'll be linking it in the description. If you guys want to look at the code that I write for my programs, I'm going to link them in GitHub along with the links to my other videos. So I hope you guys enjoy. And finally, let's get into the cool part, which is the coding. All right, so let's start here by reading some of these specifications. We have to develop a program which emulates a full deck of playing cards, which means we're going to need the 4 suits, which are clubs, spades, hearts, and diamonds. And we're going to need the 13 ranks, which are ace all the way through jack, queen, and king. Looks like, and of course it's going to make 52 cards in our deck. They gave us some mandatory methods that we're going to have to implement. So it looks like we're going to have a knit deck, empty deck, deal card, and print card. I'll go over these more in details once we implement each of them step by step, but right now I'm just giving a general overview of what we have to do. Then our main method must end with this following block of code, which cannot be modified. Okay, so this is the main method we're going to have to use for our program, and we basically can just copy paste this if it can't be modified. And then these are what our sample runs should look like. So we're going to have to shuffle a deck, and I'm assuming here that 7 is just the rank and S is like the spade. So like 7 of spades, king of spades, 2 of hearts, 6 of spades, and so on. And so the targeted output is to get a shuffled deck each time. So like it's a shuffle of 52 cards. So each card in your deck is going to be displayed in random order. And we're going to use these methods along with this block of code to output a shuffled deck of cards. Okay, so let's get started by actually creating our program. So let's go back into Eclipse and let's go to File, New, Project. Same this project name, Program 1. And I'll just do YT for tutorial. Let that baby load. All right. So let's go into new class. And let's just name this something we'll be able to recognize, shuffle deck. Shuffle deck. Let's turn the main method on because we will be using it. And press finish. All right, let's wait. There we go. Okay, took us to our main method. Get rid of this. You know, I like to keep the braces in line, and then let's copy paste that code from our parameters into the main method. Let's go here. Copy paste here. All right, and this should work. It gives us an error here. I'm not sure why we don't have double quotes around this, but it works now. So it looks like the only errors that we're encountering is that a knit deck, empty deck, deal card, and print card haven't been resolved or are like undefined. And that's because we have to actually make the methods. So let's start by implementing the first method. Okay, let's go read the parameters for the first method. I think it's right over here. Okay, awesome. So the first method we're going to have to write is called init deck. And so the return type is void and the name is init deck, and it takes in one argument, which is a Boolean array named deck. So what we want to do is set the values of the deck to indicate that they are all true, aka not dealt. So let's go in MS Paint real quick, try to explain this. So right now our deck, because our deck is type Boolean, it means it can only have 2 values, true or false. So for a card to be considered true, it means it's inside of the deck. So we want our entire deck to be true because we want to say when we initialize a deck, we want to be able to say that every single card is inside of it, which means that we're going to have to go through the entire array. So I'm just going to use a smaller array, but just imagine that this is going to be used for 52 cards. We're going to have to go through the entire array and change every single value to true. So right now, let's say that there's like false, true, false, false, true. And we want every single value in this array to be true. Well, the easiest way we can do that is by going through the entire array and one by one changing each individual value at this array. So the easiest way is by starting at index 0, which will be here. This will be index 0, and we'll go through the length of the array. So we could go through 52, but going through the entire length of the array will just be easier. So to get to this point, we're actually just going to say deck, not back, deck. I really need a drawing pad dot length. So we're going to start at index 0 and go through the entire, go until we get to the length of the deck, which is the end of the deck. And then at each index, we're going to change the value of whatever this index is to true. I guess we could say we're going to set this index to true would be an easier way to think about it. So in this case, we're going to do deck, not dex. Oh my God. Deck at index I is going to be equal to true. And this will make more sense when we actually code it up. But right now, the concept is we're going through the length of the array and changing every index inside of the array to true. So let's try to code this up. So we're going to need public static void, which is the return type, and the name of the method, which is initDeck. And then this will take in one parameter, which will be a Boolean array named deck. And so the way we're going to go through the entire array is by using a for loop. For int I equals 0, I less than deck length, deck dot length. Oops. And then we'll do I plus plus. We'll say deck at index I is going to be equal to true. So what this code does right now, and as you see, as we made initDeck, the error went away and now it's turned to green because Java can actually recognize this code after we made it. Or they can recognize this method after we initialized it down here. So what this code is doing is we're starting at index 0, then we're going through the entire deck, and we're setting each value at each index of the deck to true. So that's it for the first method. Let's work on the implementation of the second method. All right, so let's go back to the parameters. So right now, we need to make a method called emptyDeck, which return type is Boolean, and it takes in one argument, which is a type Boolean array named deck. And so what this method does is returns whether or not all the cards in the deck have already been dealt. Okay, so let's think about how we can achieve this. So we want to make sure that all the cards have not been dealt. So we already know that if a card is true, it's going to be in the deck, in deck. And if a value in our array is false, it's out of the deck, out of deck. So for our array, or for our quote unquote deck to be empty, every single value needs to be false, meaning that every single value is outside of the deck. So how we can do this is by going through our array again. I'm going to use a smaller array, but remember, we're going to be using 52 values in our array. But right now, I'll just use a smaller array for an example. So if we have some true and false values in here, say this is true, false, false. Right now, the return of this would be false because the deck is not empty because we have a card still in here and a card still here. So we want to make sure that every single value is false. So right here, this would return false. But if every single array, or if every single value was false, meaning it's out of the deck, then we would return true. True. This means that every single card in the deck is outside of it, which means that the deck is empty. So let's try to code this up. All right. So we're going to start by doing public static boolean, which is our return type, and then empty deck, which is the name of this method. And then the argument that will be passed in is a boolean array name deck. Okay, so the first thing we're going to do is we want to go through the entire deck and make sure and check what the value of each index is. So we're going to do the same type of for loop we did in this init deck method. So we're going to do for int I equals 0. Then we're going to do I is less than deck dot length. Then we're going to do I plus plus, space this out a little bit. And so now we're going to do something a little different in this body. We're going to do an if statement. We're going to do if deck at index I is equal to true, then we will return true. Oops. Sorry, then we'll return false. And then if that's not the case, we're just going to return true. Oops, actually we have to return it outside of this loop. So we're going to actually return here. Okay, so what this code is saying is that we're going through our entire deck array and we're checking if there's a true value inside of it. So we're checking if any card is still in our deck. If a card is in our deck, then we're returning false. The reason we're returning false is because our deck is not empty. If there's a card inside of our deck, then the deck is not empty. But if all cards are empty, basically saying if every value is false, meaning that there's no cards inside the deck, then we will return true because the deck is empty. So that's all that there is for the second method here. Let's try working on the implementation of the third. If I can find it. There we go. There we go. Okay, awesome. So it looks like the return type is int and the name of the method is deal card. And it takes in one parameter, which is a Boolean array of deck. So this will return a card in the int range 0 to 51 at random that has not been dealt since the deck was initialized via init deck. Also notes that in deck, this card is no longer available. Okay, so these comments are a little bit confusing, but I'll try to explain what this code is actually supposed to do. So let's get rid of my artistry here. So right now, we're trying to deal a card from our deck. Now remember, our deck is only true or false values because it is an array of type Boolean. So for the context of this example, let's just say that every card in our deck is true. Now remember, since it's Boolean, it can only be true or false. And in this case, true means that our card is in the deck, and false means that our card is out of the deck. So if we want to deal a card, we first want to pick a number that's in our deck. Obviously, this is not 52 indexes long, but just bear with me. So we're going to pick a number between 1 and 52. And the only way we can deal a card is if it's actually inside our deck, meaning that it's true. So if we're dealing a card, we have to first make sure it actually exists inside of our deck. So we're going to have to say that it's true. So we're going to pick a random card between 1 and 52. And then if that card is true, then we're going to deal it. And when we deal it, we're going to turn this true value into false. Because after we deal a card, it's going to be outside of the deck, meaning that it's false. So this true value is going to turn false. And then we're going to keep repeating this until we know that every single card in our array is false. So let's do a little example here. Let's say we have a deck of 4 cards. So we have true, 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 and true. We're going to pick a number between 0 and 3 associated with our indexes. So let's pick a number between 0 and 3. And let's say we pick 1. Well, 1 is associated with this index right here, which means it's true. So it's true. Awesome. We're going to take this value here and we're going to set it equal to false, meaning that we dealt this card in our deck and now it is outside of the deck, meaning that our new array is going to be true, false, true, true. So let's say we generate another random number between 0 and 3. Let's say this time we generate 1 again. Well, we can't deal a card that's false because we can't deal a card that's not in the deck. So if we generate a random number that is 1, we're going to repeat until we generate another number that is true. So we're going to generate, let's say for this example, we generate 2. So we generate this card, which is true. So it's true. Then we're going to set it equal to false. We're going to repeat this until every single one of these cards is empty. And now we're going to apply the same logic to this bigger array. So let's try to implement this in code. So the first thing we're going to do is actually type the name of our method, or do our method heading, or however you want to call it. So public static int, and then the name of our method is deal card. And then it takes in one parameter, which is our Boolean array of deck, or Boolean array named deck, I should say. All right, now that we have this, we're going to initialize int variable. So we're just going to do int I, just like this. And now we're going to use a do while loop. So for the do part of our loop, we're going to set this variable here to a random number between 1 and 52. So I equals int. We're going to use typecasting for the math.random function. Times 52. All right, now that we've generated a random number between 1 and 52, we want to have the condition for our while statement to be that this will repeat if we get a false card. So we're going to do while deck I is not equal to true. What this part of our while statement does is that if we get a false card, which means if we try to deal a card that's outside of the deck, we're going to keep generating a random number until we get a true one, and then we will deal it. Now we have to get to the part where we actually deal the card. So all we're going to do is take the card at the index that we found it at and set it equal to false, meaning that it's no longer inside of the deck. So a card that is inside of the deck that is true is now going to be labeled as false, meaning that it's outside of the deck. And then we're going to return this card. We're gonna spell return correctly and then deal the card. Okay. So let's break this down one more time. So we're establishing a variable. Then we're going to give that variable a random number between 1 and 52. And then we're going to keep looking for that. And then we're going to determine if it's true. If it's not true, which means if the card is not in the deck, we're going to keep looking for another card until it's inside of the deck. Then, if we find a card that's in the deck that we want to deal, we're going to deal it by setting it equal to false, and then we're going to return the value of that card. So this is how the deal card method works. Now let's work on implementing the final method. All right, let's work on implementing the final method, which is the print card method. There we go. All right. So the return type is void, and the name of this method is print card, and we take in one parameter, which is int card. So given a card, an int in the range of 0 to 51, it prints an appropriate representation of this card based on a one-to-one onto mapping of the set 0 to 51 to the cards described above. All right, this is a little complicated, but all that they're saying is that we've been using a Boolean array, which means we've been using true or false, but we want to actually give each individual card a value. That's what one-to-one onto mapping means. So when they say one-to-one onto mapping, they just mean we want our deck of cards to look like a deck of cards. So we want to make sure that we have different cards each time. So we're going to achieve that in a little bit of a complicated way, or at least I think it's a little complicated. Let me try to explain this using MS Paint. Oops. Why did I open Eclipse twice? That's pretty cool. Okay. So what we're going to do, we're going to make two arrays here. They're both going to be of type string, and one array is going to have the suits, so hearts, clubs, spades, diamonds. It won't really matter your order for either of these. And then the other string type array will be the rank. So this is going to be ace to king. You know, ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. I'm just going to write ace all the way up to king. But remember, this is all 13 ranks. 13 ranks, 4 suits. To give each one of these suits an index, we're going to use two types of division. We're going to use integer division, and then we're going to use the modulo operator. So for the 4 suits, we're going to do card, because we're passing a card, divided by 13. Then for the ranks here, we're going to do card, modulus operator, 13. Now, we're doing this because if you pass in a random number between 1 to 52, you're going to get a different output each time. So let's say we pass in 5. So we're going to do 5 divided by 13. Now in Java, when you do integer division, you can only get a whole number output. Since 5 divided by 13 is less than 1, our number is going to be 0. So how integer division works in Java is, let's say we do 3 divided by 4. This is just a random example. 3 divided by 4, it usually equals 0.75. In Java, this equals, or with integer division, this equals 0. And the reason it equals 0 is because it can only have a whole number output. There's no rounding. And if you do round, you round down. So it just takes only the whole number. So 5 divided by 13 is 0, but 5 modulus 13 is going to give you a remainder of 5. So the modulus gives you the remainder. So this is actually going to be 5. Now, if we look in our arrays here, our 0 is going to match with hearts. And then if we actually drew this out, 5 would match with I'm pretty sure it'd be ace 1, 2, 3, 4. It'd be 4. So this would be the 4 of hearts. If we passed in a 6, this would be 6 divided by 13, which would still equal 0. But then we would have 6. So it'd be like 6 modulus 13, which is going to equal 6. So you're going to get a remainder of 6, which means that you're going to get hearts. So it's 5 of hearts. So before you would get a 4 of hearts here, now you get a 5 of hearts. This will follow the same way every time. As we increase the card, as we increase the number between 0 and 52, we're going to keep getting different cards. So let's try to implement this in code. Okay. So we're going to do public static void print card. We're going to take in int card. So now we're going to make a string array of our ranks. We'll name this ranks. Actually, we'll do the suits one first. Do the suits one first. Now the fun part, typing in all of these. We'll do hearts. We'll do it in capitals. Hearts, diamonds, clubs, and spades. All right, now we're going to do the rank string, which is even more fun because there's more stuff to type. So we're going to do ace here. 2, 3, 4. This is probably everyone's favorite part of the video right now. If you're enjoying this content, like, comment, subscribe. You guys need to smash that notification bell if you haven't already done that. Oops. I lost my focus. I was thinking about the bell. I'm still thinking about the bell. All right, Jack. Let's do these in capitals too. Queen and King. Okay. Finish that up. Now we have our string array for suits and ranks. So now we can give each of these an index, just like we did in the example. So we're going to do int suit index. Suit index. There we go. Equals card divided by 13. Then int rank index equals card modulo 13. All right. Now we can get to actually printing these cards. So we're going to represent these as strings. So string suit equals suits index. Suits at suit index. Oops. Then string rank equals ranks at ranks index. Now, system oops. Do rank plus suit plus this. Okay. Oops. Looks like there's an error here. There we go. Okay. Okay, so let's explain what's going on here. We made two strings, one containing the suits and one containing the ranks. Now we gave each one of these their own individual value by making the suits index a card divided by 13 and the rank index is a card modulus 13. Now we made a string representation of the suits at the specific index and the rank at their own rank specific index, meaning that each one of these cards is their own individual card. Then we just use this print statement to print them. So all that's left is to actually test this block of code using the methods that we created. So let's just run it. Okay, so we have a shuffled deck. Shuffled the deck again, looks pretty different to me. Okay, and we shuffled another deck. All right, guys, only took me 30 minutes, but we shuffled a deck of cards. Thank you guys so much for watching. Make sure to like, comment, subscribe. Absolutely smash that notification bell. I don't think I told you guys to smash it, but absolutely smash that notification bell. Thank you guys for watching, and I'll see you in the next one.